If you think software or AI is the hard part of machine vision, it's not. The hard part is getting the same image every single time. Hi, I'm Raghava Kashyapa, CEO of Qualitas Technologies, and we build machine vision inspection systems where image acquisition is the foundation. Today, I'll show you a system that inspects tweezer tips for functional defects, and I'll explain why image acquisition is a real engineering challenge. The system checks 5 functional defects on the tweezer tips. Defect 1 is thick or thin tips. In simple terms, the tip can be too bulky or too sharp. It's like a pair of chopsticks, where one side is thicker, the grip becomes unreliable. The second is a tip shift. When the tips close, the 2 edges don't line up. It's like closing a zip. If the 2 sides don't align, you get a gap on one side. Defect 3 is front open under minimum pressure. So here there are 2 pressure settings that we apply the tweezers to close the tweezer to test it under 2 different conditions. When we say minimal pressure, we look for the closing force and ensure that the very front of the tips don't shut. You see a small gap right at the point where it should be touching. It's like a door that looks closed, but the latch isn't actually engaging. Defect 4 is an up and down misalignment under minimum pressure. This one is about depth. Even if the tips look aligned from the front, one tip can sit slightly ahead of the other. And this causes the tweezer functionality to get affected. Like trying to clap your hands when one hand is slightly forward, they don't meet flat. And the last one is a back and side open under full pressure. Here we apply a 4.5 kilo load using the load cell. And when you press the tweezers fully, the contact should be consistent along the tip area. Side open means there's a gap along the side edges even when fully pressed. Back open means the front may touch, but the back part of the contact area stays open. Using the zipper analogy again, it looks closed at the tip, but it's still open behind. Or like 2 rulers touching at the front but separated a little further back. All of these decisions depend on seeing tiny edges and gaps clearly. And the part is also reflective, so lighting, angle, pressure can completely change what the camera sees. To ensure that the consistent pressure is applied, we apply pressure using a plunger with an integrated load cell that measures how much pressure is actually being applied. This lets us apply the same force every time. But force alone is not enough. The exact position when the plunger touches the tweezer matters. The exact position where the plunger touches the tweezer matters. A small shift in contact point changes how the tips close. And that change reflects in the gap and alignment you see on the image. Even with the perfect pressure, the image can change if the part twists slightly. Because we use a backlight to see gaps, the twist can sometimes make openings disappear if the tweezer rotates. So we control the orientation using positional guides on the rotational tables. For each tweezer, we capture a defined set of 5 images, and these images cover the required orientation and pressure conditions required to measure these 5 parameters. The point is stable evidence. We want the same views captured the same way every time. So we built this as a standardized test equipment, so multiple identical machines must produce the same output. If the same tweezer passes on one machine, it should pass on the other. If it fails, it should fail on the others. That's why we control all the inputs that influence the image. Software is an afterthought. Lighting here is not just cosmetic, it decides whether an edge, a gap, or a thickness change is visible at all. On reflective metal, a glare can hide edges. Shadows can create false gaps. So we design lighting, geometry, and optics together and keep it repeatable. Once image acquisition is stable, the inspection becomes measurable. The system evaluates the image against the defect criteria and separates good and defective parts into different bins. So to conclude, it's the image acquisition and not the software. If you'd like to see a demo or map this to your defect criteria, book a demo and we'll walk you through it.